Alrighty, so now we're today working on section 4.3, which is properties of logarithms. So basically today we're just going to cover the essentials of the algebra of logarithms. So everything that you know about at some point, you learned how to do this, and you learned how to distribute, and you learned how to factor, and you learned how to do all this other stuff. That's all algebra. Well, logarithms have their own algebra, and you need to know the basics of algebra if you're going to solve you need to know the basics of these if you're going to solve logarithmic equations. So I'm going to introduce you to some of the properties. Some of them are kind of nice. I'm going to actually give you about 4. But for example, looking at the product rule, because logarithms are the inverses of, remember which function we're inverses of? We're inverses of the exponents. A lot of the exponent rules are going to look similar to the logarithm rules. So for example, in exponents, our product rule is b to the m times b to the n equals, do you remember? It's definitely something you need to have in your pocket. B to the m plus n, right? Let me move that over so I have some room. Now, logarithm laws are very annoying because they're long. So here's a logarithm version of it. Now, if you see this and you're like, that doesn't look anything like the exponent, that's not helpful at all, then just completely ignore it. I'm only showing you the exponent because I actually do think it's kind of helpful. But the logarithm law that's similar is log base b of m times n equals log base b of m plus log base b of n. Okay? So the idea is that, like over here, when you multiply two things together, this one and this one, you multiply those two things together, what you really do is you add the exponents. So here, when you're multiplying these two here together, what you're doing is you're adding the exponents. So you can actually derive this logarithm equation from the exponent. Well, I'm not going to do that because I think you would throttle me. But you can do it. It's definitely there. So it's kind of... Oh. Sorry about that. Toddler randomly begging on stuff in other rooms. Sounded like it needed attention. All right. So basically you got this logarithm property. And so, for example, you could be doing something like this. You could say, well, log base 4 of 7 times 5, for example, you could rewrite that as log base 4 of 7 plus the log base 4 of 5. You might say, well, big deal. I don't see how that's helpful at all. Well, you can actually use this property to solve problems that you would otherwise not be able to solve. Or at least simplify problems that you wouldn't be able to simplify otherwise. So for example, if I had something like log of 10x. So I have log of 10 times x, and that's the same thing using our property as log of 10 plus log of x. Now we can simplify this because we know that when log is by itself, it has a secret base 10. We know that log base 10 of 10 is 1. So you see that maybe you might be able to imagine that one day it might be preferable to be able to simplify this into something that looks like that. If you're going to be solving an algebraic equation, you get the x by itself, and now all of a sudden maybe you've got something that you can solve that you couldn't solve before. So that's kind of an example of what we would be doing with this. Okay, so if you are in the mood, go ahead and start yourself a master list. So I'm going to make myself a master list of properties. Okay. Now on there you should have some stuff that we had before. We had log base b of b was equal to 1. We had log base b of 1 is equal to 0. We had, let's see, b to the log base b of x was equal to x. We had log base b of b to the x being equal to x. Now we've got log of m times n is equal to, or log base b of m times n equals a log base b of m plus log base b of n. And we're going to continue to add to this throughout the lecture here today. Okay.